Hi, this is Flash. Let's do this. Okay, 10 kilogram asteroid is traveling through space at 2 meters per second. Recall that momentum equals mass times velocity, a vector equation. Vectors will be important to hint for the extra credit. So, uh, let's see here. Okay, I've got a mass of 10 kilograms and I have a velocity of 2 meters per second. That means I've got a momentum of 20 kilogram meters per second. If I do a rocket that exerts a force of 20 newtons in the opposite direction for 5 seconds, if we draw our force profile for that, our impulse is 20 newtons, assuming it's a constant force for 5 seconds. The area under that curve is my impulse, so we've been calling impulse J. Again, it's a vector equation. J equals 20 newtons times 5 seconds. And if this is positive, let's say the asteroid is going in the positive direction. Asteroid. This is its velocity. Then the astronaut is going to exert an impulse in the opposite direction. And so we think due to impulse momentum theorem, impulse momentum. I just realized it's probably pretty annoying when I write off the paper. Sorry. Impulse momentum theorem says J equals the change in momentum. Final momentum, J equals final momentum minus initial momentum. J plus initial momentum equals final momentum. And that means, or taking that up here, what I've got is 20 newtons times 5 seconds. And we said this was a minus, plus the initial momentum, which was 20 kilogram meters per second. Those are the same units. You can double check me. A newton is a kilogram times a meter per second squared divided by second. Times a second is a kilogram meter per second. And so what you've got is 100 minus 20, minus 100 Newton seconds plus 20, we can just say Newton seconds again, is minus 80 Newton seconds. So that's the final momentum. Final momentum is mass times velocity, so minus 80 kilogram meters per second equals the final. I'm just fooling around with units, changing the units again. And then if final momentum is mass times velocity final, minus 80 kilogram meters per second. Kilogram meters per second. Then if I divide minus 80 kilogram meters per second divided by the mass of the asteroid, so 10 kilograms, I should get that the final velocity is minus 8 meters per second. And so that would be in the opposite direction. So that would be, you would reverse the total direction of the asteroid and it would send it off in the opposite direction. So the final velocity (8 meters per second) backwards, or in the opposite direction. for some reason I thought they were going to try and slow it down or stop it. We can figure that out. That's, of course, the next question. How long should she have pushed in order to just stop the asteroid? Okay, so that's kind of a hint that it did end up reversing it completely. Let's say that now the impulse equals a change in momentum. If I have final momentum minus initial momentum, and I want my initial momentum minus I want my final momentum to be 0. So I want my impulse to be equal to minus my initial momentum. Don't forget your vectors here. Just keep things straight. Is that okay? So, but I want final momentum to be equal to 0. So I throw that out. Now I've got how long should she assist? So 20 Newton rocket pushing for t seconds equals the initial momentum. Remember, the velocity here is a positive direction, so that equals yeah, that equals minus momentum mass times velocity. Oh, but this momentum is in the opposite direction, so we have a minus sign off. That's what I was confused about. Sorry about that for a second. But the mass times velocity is minus 20 Newton, sorry, minus 10 kilograms. Minus 10 kilograms times 2 meter per second. So that means that I really, a positive sign, sorry, negative becomes a positive. This is 20 kilogram meters per second. This is 20 Newton seconds. So T, all of this implies, sorry, that T equals 20 kilogram meters per second. That's the right side of the equation, all over 20 newtons. And that is going to basically give you seconds. So T looks like it equals 1 second. So T equals 1 second. We blew it for quite a long time. We fired this rocket and it totally reversed the asteroid. Then the question is, if you just want to stop it, maybe 1 second, then the extra credit is like maybe you could get by even cheaper by just deflecting the asteroid. What would that look like? And so that's a hint for the extra credit. But that's quiz number 28. Thanks for listening.